If you're new to the HVAC field, one of the first questions that might come to mind is, how does a heat pump actually work? How is it different from a chiller? And what does the refrigerant circuit really look like? Don't worry, I'm here to walk you through it in simple terms. Heat pump versus chiller. A chiller produces chilled water by absorbing heat from the building and rejecting it outdoors. Its primary job is cooling. A heat pump, on the other hand, can do both cooling and heating. It uses the same refrigerant circuit as a chiller, but with a reversing valve that can switch the direction of refrigerant flow. This allows the evaporator and condenser to swap roles depending on the mode. So, while the layouts look very similar, the heat pump adds versatility. Regardless of whether the refrigerant is R410A, R32, or a newer low GWP option, the working principle is the same. The only differences are in the pressures and temperatures at which the refrigerant operates, plus some added safety components in newer systems. Let's walk through the chilled water production process step by step, starting at the compressor. 1. Compression. The cycle begins as low-pressure, low-temperature refrigerant vapor enters the compressor. The compressor compresses the vapor, raising both its pressure and temperature. The refrigerant leaves as a high-pressure, high-temperature superheated vapor. 2. Heat rejection, condenser. From the compressor, refrigerant passes through the four-way reversing valve, which decides if the system is in cooling or heating mode. In cooling mode, refrigerant flows into the condenser. Here, it rejects heat to the atmosphere, air-cooled, or to condenser water, water-cooled. As heat is removed, refrigerant condenses into a high-pressure liquid. 3. Filtration and cleaning. The liquid refrigerant passes through a filter dryer and sight glass. The filter dryer removes moisture, dirt, and contaminants. The sight glass allows visual inspection for bubbles or impurities, ensuring the refrigerant is fully liquid before expansion. Next, refrigerant enters the expansion valve, TXV, or electronic. Here, it undergoes throttling, where its pressure and temperature drop significantly. The refrigerant leaves as a low-pressure, low-temperature liquid vapor mixture. 5. Heat absorption, evaporator, chiller barrel. The cold refrigerant mixture enters the heat exchanger, which in this mode acts as the evaporator. Inside the heat exchanger, chilled water circulates through tubes. The refrigerant absorbs heat from the water, causing it to boil and turn into vapor. The water leaves the heat exchanger cooled. This is the chilled water that goes to the building's cooling system. The refrigerant, now a low-pressure vapor, returns to the compressor, and the cycle continues. The pH diagram and refrigerant circuit with arrow direction for each process explains the whole process. In the diagram, I added typical pressure and temperature value for R410A refrigerant in different working stages. When the heat pump operates in heating mode, the refrigerant circuit shifts roles with the help of the four-way reversing valve. Here's the step-by-step process, where the refrigerant flow in the heat pump in heating mode is indicated with arrow direction. 1. Compression. The cycle begins as low-pressure, low-temperature refrigerant vapor enters the compressor. The compressor raises the refrigerant to a high-pressure, high-temperature superheated vapor. This vapor is now ready to release heat into the water circuit. 2. Heat release, condenser, water heat exchanger. The high-pressure vapor passes through the four-way reversing valve and enters the heat exchanger, which now acts as the condenser. Here, water circulates through tubes on the opposite side. The refrigerant rejects its heat to the water, raising the water temperature. As the refrigerant gives up its heat, it condenses into a high-pressure and high-temperature liquid. The water leaves the heat exchanger warmer. This is the domestic hot water or heating hot water supplied to the building. The liquid refrigerant next flows through the liquid accumulator, filter dryer, and sight glass. The filter dryer removes moisture and contaminants. The sight glass allows visual inspection to check for bubbles, dirt, or incomplete liquid state. 4. Expansion. The refrigerant passes through the expansion valve. where it undergoes throttling. Its pressure and temperature drop sharply. The refrigerant leaves as a low-pressure, low-temperature liquid vapor mixture. Heat absorption, evaporator, outdoor coil. This cold refrigerant mixture enters the outdoor coil, which now acts as the evaporator. Even in cold weather, the outdoor air contains usable heat. The refrigerant absorbs this heat from the ambient air, boiling into a vapor. The air leaving the coil is cooler, and the refrigerant is now a low-pressure vapor. The refrigerant vapor flows through the four-way reversing valve again. From there, it is directed to the liquid separator, also called a suction accumulator, which protects the compressor by ensuring only vapor, not liquid, enters the compressor compartment. The refrigerant is then returned to the compressor suction port, where the cycle begins again. So, to wrap everything up, remember that a heat pump doesn't actually create heat. Instead, it moves heat from one place to another using a closed refrigerant circuit. No matter the application, the cycle always runs through the same 4 key processes: evaporation, compression, condensation, and expansion. At the end of the day, heat pumps are efficient, versatile, and sustainable solutions for providing both cooling and heating in a single system.